Boom! Hello and welcome back to Calculus 2 Exam 3 review. There's the enthusiasm right there. So in your infinite wisdom, you picked to have Exam 3. So there will be Exam 3 in 2 days. Then there will be no exam. Just like that. You have a choice of yes or no.
Do we all get a 0?
And no. Why would you get a 0?
That means your average is going to take.
Yeah, there's just a 15% move to the final. The final is 45%. It's fine, easy. Anyway, so chapters 8 and 9. That's not 17. That's 8 and 9. We are talking about sequences, series, and power series. And first we talk about the list, then the short story about the whole thing, and then open for questions, as usual. So first we start the sequence. Definition, you must know that the sequence is the ordered list of numbers. And then limit test for sequence, converge or diverge, right? So, and that's where the sequence, no. How to obtain formula for AN. Meaning, if I give you the string of numbers, like let's say 1/2, 1/4, 1/8, 1/16, you need to be able to put that into 1/2 to the n, and stuff like that.
Are we going to have those alternating?
Well, that's for the series. That's next.
Yeah, what section was that?
Very first section.
Oh, okay.
Yeah, years ago. Now we're moving to series. Again, no definition, which means series is the sum of the sequence. They can be finite, they can be infinite. We only focus on infinite series. Then we have the 10 tests, which again give you convergence or divergence. Now from those 10 tests, we put those into two categories. There is a category where sum is known, and that is geometric and telescoping. Very good. And there is the one that its sum is unknown, and I'll say other 8, which are the root, ratio, integral, p-series, divergence, everything else. Now, I told you 15,000 times so far, if you memorize this sheet verbatim, everything on it, this chapter reduces down to simple algebra and manipulating terms. That's it, taking limits. If you don't know this sheet, well, this is still a living hell then for you. We'll talk about the major things. So you all have the sheet. So we have those 10 tests. And then we have power series. Again, no definition. And we need the radius, well, interval. Interval and radius of convergence, mainly using ratio test, sometimes using root test if it's easier, but those are the two tests that generally we use. So interval and radius of convergence, and then find few terms of Taylor series, and calculus. So calculus with Taylor series, and I think that's it. It's very short list.
How would you define power series? Other than just give notation?
Yeah.
Okay.
Definition of power series. Oh yes, we'll deal with that. Yeah, definition of power series. Okay, I'll write it here. So definition is ck x minus a to the k from 1 or 0 to infinity, whatever. So that was the general case with the one that is centered at a. If that a is 0, right, for Taylor series, Cohen Maclaurin. Exactly. Good. All right, so now
on the test, are you gonna ask us for what? For if you convergence or divergence?
yeah, well, some tests. So I'll tell you that right now. Exactly. So the first order of business is to dig up that page number in the textbook. So give me just 1 second over here. There it is. So the page 648, I'll write this in blood. Problems 40 through 69. It says, choose your test. Some problems will say, use the integral test to check for convergence and then power series. Series. Or use root test or ratio test. Some problems will just say, check for convergence. Check for convergence means you need to know which test to use by looking at the paper. So I would say 2 power series problems, or 3, maybe 3. 1 to find power series, 1 to do the calculus with it, and 1 to do the radius integral convergence. Now I might combine the 2 in 1, right? Where you find power series and then integrate or differentiate. So that could be combined into a single question. So, but let's say 3 questions on power series. And then the rest is chapter 8. So say 7 questions. Now you have 10 tests. But you have to realize that within your comparison tests, you deal with a series, right? So that's 2 tests in 1. Within your alternating series, you can end up with any other test. So that's 2 tests as well. To see how they combine? We obviously use ratio test in the power series for radius of convergence. So are we down from 10 tests to like 6? So it's very easy to write a comprehensive exam that covers all 10 tests plus the power series in 10 questions without having 15 questions. So I'm just going to give you an example. So if you see a power series, if you see a regular series, it says this, -1 to the n, and you have, let's say, n squared plus 1 over n factorial. Tell me. Alternating series. There is no doubt about it. There's no doubt about it. You see the alternating term, question over, right? That's it. But I heard some of you scream ratio test. Yes, this part over here, when it gets down to convergence, and now is it absolute or conditional convergence? It's going to be the ratio test on this part. So you see how alternating plus ratio test in a single question, right? So that's a possibility. I'll just put like this and say ratio test later to distinguish between absolute and conditional convergence. Another thing would be, let's say you have, Mark, you talked about a very good problem, I forgot, with the ln.
1 over k squared ln of k.
And that was, there was a comparison, yes. So 1 over k squared, n squared ln, oh, that's n now, so, okay, k squared, fine. Or use pens? From 1 to, no, from 2. I know it has to be 2 because I have ln k there. If you put 1, it's 0 in denominator and the whole thing explodes, and then that's not good. So this question is really cool. Kind of takes it away from the exam, but hey, it's always the next semester, right? What do we compare this to? And sometimes knowing graphs and PreCalculus2 helps a lot. We all know that ln x graphs this way, and we all know that the square root of x graphs this way. Aren't they kind of the same? So if I want to compare this to something, I better pick that Bn to be 1 over k squared times root x, which is 1 over k to the 5 halves. Summation of 1 over k to the 5 halves converges by P series. So, and now you just run the limit. I'll just write here, run limit comparison test. You just put in the limit and you get the finite value and you're good to go. So, is that 2 tests in 1? Yeah, that was a P series, right? And limit comparison. So, you know, they combine. But before you do anything, guys, on this, now obviously if the problem says use integral test, that's the end of the story. You're using integral test with all of the proofs and everything else. But you are going to have at least 5 problems with series that says converge or diverge. So what do you do there? Yes, divergence test first. On your sheet, the first top line, right? You try divergence. You might knock out 1 or 2 of those with the divergence immediately. If the limit of the sequence is not 0, diverge. So, you see a problem like this. Summation 2 to the k from 1 to infinity. Yeah, everyone wants to scream, geometric! It is geometric. And R is bigger than 2. But, you know what? Who cares? Limit 2 to the k as k goes to infinity is equal to infinity. That's not 0. It diverges by the divergence test. Can you do the geometric? Sure. 100% credit, 100% everything. But divergence test is the one that kills that quickly. Summation of n factorial divided by 2n cubed from 1 to infinity. Everyone screams ratio. And I say, hell no. N factorial much faster in terms of rise than the polynomial. So limit of this thing is going to go to infinity. Not 0, boom, divergence. I'm not going to even bother looking at the ratio and spending 15 minutes cranking all of those calculations for no reason. If the problem was swapped with the n factorial on the bottom, our test is inconclusive for divergence. Therefore, I have to crank the ratio test there. But you want to try immediately against whatever number of, let's say 5 problems, which says just converge, diverge. It doesn't specify what to use. You want to run against all 5 of these. You want to run this test. And hopefully you knock out 1 or 2. And then the rest, you go and you ask, is this geometric? Is it telescoping? Telescoping is a little bit tricky because you can use the partial fraction decomposition. Remember that one? Right? But again, guys, you can, you might be, since you're not experienced in this yet, right? And for most part, algebra is terrible, right? You remember the problem like this, which I solved in class using partial fraction decomposition and then using telescoping. But just thinking a little bit, because you have powerful tools, instead of sitting there and cranking telescoping for 7 hours, 1 over n squared plus n. So what should we do? See, I didn't do the standard thing. Comparison, very good. Bn 1 over n squared, summation 1 over n squared converges by p series. We are expecting this to converge. This does converge by telescoping series, we know, because we spent 30 minutes cranking this thing in lecture. If you go back, this example was done in class by telescoping. But just do the limit now. One step, one little limit, done, right? So don't be closed-minded. Try other options. And no better way to practice that than to go and bleed over these 30 problems that are presented to you on 648. You look at those problems critically, right? Try to figure out what is the appropriate response for each one of them. Try one way, try another way. Right, 55.
Ratio.
Clearly ratio. You have a geometric piece with the factorial, with the boss, right? K to the k over there. That's the fastest rising function. So the question is, would 2 to the k times k factorial be faster than this? Right? You have to understand, dictators fall. All right? Dictators fall. If this is the fastest rising function ever, I can construct faster. It's not going to be basic, it's going to be composite, but maybe a square or some combination of these puppies are going to be faster than this. Maybe this in the limit is going to be infinity, and this problem dies by divergence test without touching the ratio. What does that mean? That means that you have to try and see whether it's going to work out or not. Here are your problems to practice condensing, right? Into a series, and then from there running the appropriate formula. So there are a lot of cool things to work on. Observe your root test. 2k squared? Yeah, root. A root is going to kill one of the k's, right? The other k stays. Yeah, it looks like some kind of E thing. I don't know. So there's a lot of things that you can consider. Some of the diabolical questions, you know, you don't really have to consider, but this compared to what? Which is? Pi over k cubed. Good.
Oh.
So, yeah, you get to 3, 8 minus 11, right? So this is where your 2 days should be spent, and then some power series on top of this. So this is it, where you are running. Now, you know, these diabolical questions like 64 and 65, right? Those are crazy questions that, you know, you don't have to consider. But, you know, stuff on top, sure. Basic comparison tests like this. This is integral test, clearly. Right? You can integrate ln x over x. It's a basic u sub. So it's a one-step thing, but you have those 3 proofs that you have to go through to make sure that it fits. I already talked about this one, right? Compare it to 5 halves. Should be convergence of some kind. And Mark, you had that interesting problem with factorials. This is similar, right? It was just this with 2s.
Yes. Yes. Number 17. Yeah.
Number 17. All right, let's take a look at that. Generally, the algebra of factorials. I'll just finish this, because you still have to do the test. Let's take a look at your problem was n
Factorial, all of that
squared
over 2n, all of that squared. I don't know, just like that,
And then from 0 to infinity.
If you want.
All right. Factorials equals ratio test. Factorials equals ratio test. Can we all say that? Factorials equals ratio test. See? There we go. So algebra here is the trick. We know that we need, for ratio test, we need the limit of an plus 1 divided by an in absolute values. And n goes to infinity. So I have to deal with n plus 1 situation. So I'm going to create an plus 1 and deal with the algebra of that first, and then I'm going to go and deal with the problem. So here we go. I have n plus 1 in parentheses, and then I apply a factorial, and then I apply square. If you miss this writing on the board, here we go again. N plus 1 replaces n. Then I need factorial on that. Then I need a square on everything. Same on the bottom. I have n plus 1 that needs to be doubled, and then factorial. One more time. N is replaced with n plus 1, and then I need that doubled, and then I need the factorial. Now I have to peel off terms. I peel off n plus 1, and there's time n factorial, everything is squared. On the bottom, I have to distribute 2 into 2n plus 2 and that is the factorial there. On top, in the numerator, the square, hate to say distributes, square gets applied to both of the factors. So I have n plus 1 squared and then n factorial squared. And in the denominator, I have plus 2. I have to peel off 2 terms to go back to 2n because I need 2n. So 2n plus 2, 2n plus 1, and I'm left with 2n factorial. And that's what was a mistake as you guys were practicing your homework. So now, this is my an plus 1. Great. Where's my limit? N goes to infinity. I have my n plus 1 squared n factorial squared divided by 2n plus 2, 2n plus 1, 2n factorial. Don't forget the absolute value. Times, I'm immediately flipping the original one, which is 2n factorial, and then n factorial squared. And now, this cancels this cancels this, and the whole thing is 1/4, which is less than 1, which is convergent by ratio test. Yeah, this one right here. I know, they sneak in. Those are little critters, evil. You can't, this actually helps. Can't peel here. That's generally where the mistakes are. So you can't peel there. You have to distribute, and you see that you have to kick out 2 terms. Now, if you guys saw me do this, right? Problem 52 in a cluster, I'm not doing this. Problem 52 is the same thing, except now it's k factorial cubed over 3k factorial from 1 to infinity. And you get to do the same problem with more terms and more, so there's your practice right there. So now I show up on the exam and I put, you know, k factorial to the 8 divided by, so you just have to write for 35 minutes, you know, peel off 8 terms.
Can you explain me again how do you can the 2n plus 2 factorial?
This one?
Yeah.
So factorial, n factorial, is 1 times 2 times 3 times 4. You know what? Let's go with 6 factorial. Times 5 times 6, right? If you look at this now, you see the last 2 terms? Would you agree that this is 4 factorial here? Times 5 times 6. So I can peel off 2 terms, and it's left with 4, right? So now I have 2n plus 2, and I need to go back into 2n, so it cancels. So 2n plus 2 means that I need to peel off 2n plus 2 term, and then I'm left with 2n plus 1 factorial. I need 2n. So peel off 2n plus 1 factorial, and then you're left with this one. So that's the same thing, like I peel off 6, and then I peel off 5, and then I'm left with 4 factorial there. Do you have any questions, concerns, anything that you would like to discuss? Or this chapter is way too easy, so we can go home?
What are the exact problems that are going to be on the test?
I don't know. Today's Tuesday. Test is on Thursday, so.
Thursday.
Oh. Perfect. Today's Monday, test is on Wednesday, so yeah.
How many questions
So they don't
are there
exist
going to be
yet.
for chapter 9? Can you like, it was an approximation, like how many?
Didn't I say 3?
Did you?
Where were you? Spaced out?
Yeah.
So yeah. I think I said, well, no, I know I said 3, but might be 2 if I combine them. So power series, you are expecting, again, you are expecting the radius of convergence and interval of convergence is one question, and then find terms, and then calculus. Yes?
For like if you're going to Taylor expand sine of x squared, is that just what you would normally do? You would Taylor expand sine of x and then plug in that x for x squared?
Very good.
Okay, so makes sense.
It's the function composition.
Okay.
You will replace x with whatever crazy thing x is. So sine of 3x to the 5th, you go expansion for sine, and then you replace every x with 3x to the
And
5th.
if it's centered at something, then you
Minus a, yes.
Okay.
Very good. And then you integrate, because you get the polynomial, integrate, differentiate, limit, whatever.
So for the quiz that we're doing online, there was like a function, and we have to get the first non-zero term, second non-zero term, third non-zero term, and then they asked us about the summation of the whole thing. We have to get that one.
Summation. Oh yeah, I know.
No, we're not.
It helps with differential equations later on, but there's just a finite amount of time you have on the test to sit there. So simple summations you should be able to quickly put together. Like 67, 68, 69. Right? On the page 648. Like this stuff you should be able, like this. Right? All of it.
The properties of power series, the third case.
The function composition, right? Which is the, what was Matt talking about?
Oh, an example for
Which problem? Oh, it's not wrong.
oh no, I just wanted to ask you about the third case of properties of series for power series. Yeah, so once we have converged all of them, so the interval of convergence are infinity and the value are infinity. For the second case, if we don't have a value of for k, then we are looking for convergence and then we value.
Well, this one always converges.
Yeah, this one always converges. The second one,
The second one doesn't converge.
so we convert the third case. And we can use infinity. Can explain that to
Only if x is 0. If x equals 0, kill that, and convert it. 0 less than 1. So if x is 0, then the whole thing is 0, and that's less than 1, it converges. If x is anything else but 0, you have infinity on the k part. So you pick any number for x other than 0. It will be multiplied by infinity, and it's infinity, which means bigger than 1, and it diverges. So, right? But you look for convergence, which means it only converges when x is equal to 0. So if x is equal to 0, you have convergence, but it's the only point at which it converges. So your radius of convergence is 0, your interval convergence is just 0, because it converges as a single point. Easy. Seems you guys know everything. I'm just gonna make a difficult test then because you can show off.
You're good.
Maybe
We're just gonna study.
You can make it like as possible.
Going to make the series test and then you make sure it converges to 100. The grade.
That's not you.
The final. It's worth more.
How is it final?
You just show up. It's final.
It's a department. Exactly.
Oh my god, be the same.
So any questions, concerns? Anything else? Or should I shut down the store? All right, I'll see you in 2 days. Happy study.